Good evening. So as promised, here's a video workup of how we've got the temperature and humidity now sensor working with parts straight out of the box from the S4A Silver, S4A Elements Silver kit, which you can buy today. So here we've got our Arduino clone with a Grove shield and the Grove parts that come with. We've got a neopixel stick here, which is super bright, so it's kind of hard to see. You can see some red and some purple LEDs there. Then we've got the temperature and humidity sensor right there. And the way this is all hooked up in code, I'll just come over to the code now. So here we're looking through the code. You can see the example project. This is easily found by just going into the S4A Arduino community site, which is on GitHub. It's got lots of example Swift code on there, lots of helpful libraries, things like that. And if you download or clone it, then you'll find a folder for the S4A Elements example code, and within there you'll find the thermometer and humidity sample, which is what we got here. So if you look at it, aside from the standard template, we've got a couple of libraries that have been added. So if you haven't done this before, the way you add in libraries, which also come from the S4A Arduino community site. Firstly, you can download them using download libraries, and that will download a copy onto your local file, onto your local hard drive, and then you can add and remove them just by ticking boxes in here, and as well as adding them in here in the line where they're going to get compiled in by the build script. It'll actually add in any snippets that are associated with them down here. And I've already done all that, so you can kind of see this as an example. This is the code going down from here. So we've got a few constants to begin with. So some of these things are just going to always be the same for the S4A Elements boxes. So the LED stick always has 10 pixels on it. So the number of pixels down there is written as 10. And then the others are going to depend on where exactly you plugged your Grove parts in, which part of the board you plug them into. Right now I've plugged the LED stick into port 4, and I've plugged the DHT11 sensor into pin 2, into the port for pin 2. Then set up there are standard snippets for this that you can just drag out of the snippets folder. Set up a buffer for the neopixels, and the important thing, which I've shown in other videos, is that we need to say has white chip false. So the default snippet when you drag it out says true here, but actually the neopixels that come in the S4A Elements Silver box don't have a white pixel on them. There's the more expensive chips. These are smaller and slightly low power, so these just don't have just normal RGB values, and you can construct 3 of those together to make white if you want it. The rest of these are being passed in from constants, so you can see that. And here we're making a color for use later, so using purple, and you'll see why that is in a minute. So here's the crux of the program, which is really simple. In a while loop, every 2 seconds, we've got 2 seconds delay here down the bottom, we get the temperature reading. And this value here, read values, comes from the DHT11 library, and it returns a tuple, which is the temperature, the humidity, so it's temperature in degrees centigrade. If you want Fahrenheit, you'll need to do a little conversion, the usual multiply by 9, divide by 5, and add 32. The humidity, which is a percentage from 0 to 100, and is valid, which is a flag, which actually I'm not checking that in this particular program, but you would normally, I guess, check that. And that really just determines that if the values that are coming back there are valid, or if you're getting, if the sensor's reporting a problem, like if perhaps if it's unplugged or something like that, or if you're reading the values too often, like if you read them more often than once, if you read them like multiple times per second, you'll start getting invalid values coming back. So normally it's worth checking this just to check that you're not getting duff data, but it's entirely up to you how you write the program. So what I want to do, because we've got 10 pixels on the stick, I want to measure the sort of range of temperatures that you would have. So I'm saying temperatures from, say, 0 to 40 centigrade are the kind of temperatures we'd be interested in, something from a refrigerator up to a really hot room, or really hot outdoors. So I said if you take the temperature in centigrade, divide by 4, and you'll notice here, because it's Swift and it's very strict about integers so that we can't avoid all of the kind of undefined behavior and weirdness of C, you have to actually explicitly marry up the types. Because the temperature comes back as an int 8, we're going to need to divide it by an int 8. So we want to divide it by 4, but I'm casting 4 to an int 8. We're using it as a constructor technically. This then gives you another int 8 value, which is basically how many of the neopixels you want to light up. Like if it's 12 degrees centigrade, then, or 13 degrees centigrade, then this will come in as 3, and so on. We do a similar calculation for humidity, but we're dividing by 10 because it's 10 pixels, it's 0 to 100. And then we iterate through the pixels. And again, we're casting the integer values here. So we've got, that's going to be 10 because you've got that up here. And we're basically saying from 0 to 10, we are going to iterate through each of the neopixels and decide what color to make it. So we've got nice tight Swift code here. We basically say put a tuple here in the switch statement if we're underneath the temperature lights number. So if it's like we should be lighting up 3, and we're underneath the humidity lights, then we'll have red and blue, which is purple. If it's just temperature, we'll have red. If it's just humidity, we'll have blue. And finally, if we're above both of those, if you're the top few LEDs here, then you'll have neither. Once the buffer's been set to all its values, and again, we've got to be careful here because this index requires an int, and we've actually used an int 8 here, so we need to cast it to an int, otherwise this won't compile. Swift is very strict on these things, quite rightly so. Then we finally just flush the buffer out to the neopixels, wait for 2 seconds, and back on the loop. And that's all it is. So now you'll see an example of this. Okay, you can see the project a little bit more clearly now that I've cleaned up the lens on the camera a little bit. So you can see here, it's blurring a bit, partly just because it's so bright. And the colors would be much clearer if you're doing this in yourself, but this is showing we've got 5 neopixels lit up purple, which is about 50% humidity out of 10, and 6 neopixels you see you've got with the red that's going up to 6, which is 6 times 4, which is about 24 centigrade. So it's saying it's about somewhere between 24 and 27 centigrade in the kitchen tonight, which is about right. So if I take the sensor here, I've got a cup of boiling water, or just recently boiled water. If I hold it over there, then we'd expect to see the humidity to jump. There it goes, right the way up to 100% humidity. And because there's some temperature in there, it'll actually, the temperature will creep up. So that's a little bit slower. The response on that tends to be, okay, we can see that it's gone up to 7 and then 8. And if we take this away, what I found with this sensor is the humidity responds pretty quickly. So because that was an extremely humid environment and possibly even condensation, it will take a while for the humidity and temperature to die down again on the sensor. The sensor's got some thermal capacity, so it'll be a while before it drops down. You can see the humidity going back down, but the temperature will take a while to go down. And that's it. Please do post comments, likes, share, let me know what you think, what you're interested in. And above all, do take a visit to our website, which is www.swiftforarduino.com, or have a look at our project site where you can buy one of these kits yourself, S4A-elements.com, and you can buy one of these kits and be coding today, writing Swift as you've seen.